building information modeling, a preview, and then move on to some 3D Max advanced modeling and rendering issues for developing your final project, not directly relevant to your final project. Your final project has its own topic, scope, idea, but today's issue is lecture and given lab exercises, not developing your final project, okay? And then move on to the guest lecture. So let's get started. I would like to show you again those two diagrams representing history of design computing. It's a kind of short timeline, short chronicle of computer-aided design. First, CAD introduced early 1960s. First, solid modeler in architecture field introduced, and also 3D building design by computers introduced in middle of 70s. And also some more events. CATIA, it's kind of complicated parametric modeler invented in early 80s, and parametric modeler and World Wide Web introduced, and the kind of industry, one of the industry reading BIM authoring software, Revit introduced, SketchUp released to public, and some kind of smart devices, iPhone, iPad released in the middle of 2000. And anyway, this slide shows you some brief overview of history, timeline. Just for 30, 40 years, not that long history. But there are very huge changes we have been encountered. First CAD system named Sketchpad, but recently we are using some Revit or some related BIM software. Ironically, iPad, iPhone, also they use some similar term, Sketchpad, even in early 60s. I would like to put an emphasis on where we are in terms of history of design computing. It's related to the advances. When we believed 2D drawings are design, geometric drafting in 2D were design, and people moved to 3D, just 3D visualization using surface. There is no solid objects. Amount of surfaces generate 3D object. So that is so-called surface modeling. For representing realistic and mathematically real objects in architectural, tangible real world, people invented 3D solid modeler, which is possible to do some Boolean operation, plus, minus, something like that. That is so-called solid modelers. And parametric modeling. And nowadays, we are focusing on information modeling. We are dealing with building. So that is BIM, building information modeling. One of the major technologies is parametric modeling. I simply put this diagram, height with steps, for controlling the size of that cube. But actually, simply think about how to control windows. You can put window height, and then window's height is really changed, not its geometric shape. In other words, the window size is going to be changed. Frame size is going to be same, even if you put 2 meter height, 1 meter height. But if you change the height using 3D Studio Max, also frame size, frame thickness, they all going to be relationally updated, because that is just geometry, not window object. That is parametric modeling anyway. we are here in this semester using SketchUp and 3D Max. Precisely say we only deal with surface modelers because SketchUp, 3D Max, they are all surface-based modeling tool. But some features of solid modeling tool, but not really solid modelers. In other words, in terms of its development, its evolving history, we are still in kind of primitive level. So using 3D Max doesn't mean you are in kind of some cutting edge, but you can be in cutting edge rendering skills and modeling skills within that level. But anyway, today's topic is building information modeling. So my question is, what is BIM? What is building information modeling? I found a very useful video for beginners made by Graphisoft. Graphisoft is one of the leading CAD companies, mostly European based. ArchiCAD is their representative BIM authoring tool, BIM-based design tool. Let's take a look at this video. Okay, while video is running, please pay your attention to the video. Actually, those videos, my demos are mostly from YouTube, open to public. So you can search them, but you don't have the file. Only my computer will show you the file. So let's take a look at some videos. Some series of demo videos prepared for today's lecture.
What is BIM? BIM is very much talked about in the building industry, but what is it really? What is it used for?
And who should use it? Some say BIM is a type of software. Some say BIM is the 3D model of buildings. Others say BIM is a process, or that BIM is nothing more than an organized collection of all building data. BIM is all of the above and more. Now let's see BIM explained in layman's terms. When it comes to BIM, everything begins with a 3D digital building model. This model, however, is more than just simple geometry and some interesting textures added to it for visualization. A true BIM model consists of the virtual equivalents of the actual building sections used to create a building. These intelligent elements are the digital prototype of the physical building elements such as walls, columns, windows, doors, stairs, etc., that allow us to simulate the building and understand its behavior before the actual construction begins. Now let's see what a BIM model can be useful for. 3D visualization. Of course, the most basic use of a BIM model is for creating realistic visualizations of the planned building. Your BIM model helps your design decisions by comparing various design alternatives and for selling your design to your client, the local community, and other stakeholders as well. Change management. Since data is stored in a central place in a BIM model, any modifications to the building design will be automatically replicated in each view, such as floor plans, sections, and elevations. This not only helps in creating the documentation faster, but also provides stringent quality assurance by automatic coordination of the different views. Building simulation. BIM models contain more than just architectural data. Information about the different engineering disciplines, sustainability information, and other characteristics can be easily simulated well in advance of actual construction. Data management. BIM contains information that is not visually represented at all. Scheduling information, for example, clarifies the necessary manpower, coordination, and anything that might affect the outcome of the project schedule. Cost is also a part of BIM that allows us to see what the budget or estimated cost of a project might be at any given point in time during the project. Needless to say, the data put in a BIM model is not only useful during the design and construction phase of a building project, but can be used throughout the entire building life cycle, helping to reduce the operation and management cost of buildings which is significantly more than the entire cost of construction. With all the benefits BIM has to offer, don't let your competition get to BIM before you do.
Visit www.graphisoft.com/BIM.
To sum up, this video shows you BIM is not just geometric model, such as your AutoCAD file or 3D Max modeling file. Of course, that is very important, one of the very important parts of BIM geometry, but this is just one type of information you can contain in your BIM model. So, in other words, BIM is kind of integrated computational model, collection of your information about your building. That means BIM can be used not only for design, but also rest of other building life cycle, for engineering, for construction, even facility management, maintenance, probably for hundreds of years. Okay, that's major issue we have to tackle. Okay, let's get back to some higher level. This is kind of advanced cutting edge information technology, not just geometric, graphical or computer graphics issue. It's something about IT. So why we need IT-based technologies in our domain, so-called AECFM industry, architecture, engineering, construction, and facility management. My lab name is Design IT Lab, and some others have AEC IT Lab or Construction IT Lab, and so on. So what those terms refer to, that's the question. Let's talk about some productivity issue. My question is how to enhance the productivity in AEC FM industry. Let's take a look at this one. Reference BIM handbook, originally from Stanford Sci-Fi. Labor productivity in construction and non-farm industry. Non-farm industry refers to some mechanical engineering, automobile, cell phone, computers. Anyway, general industries compared to our industry. So this is AECFM, AEC industry, architecture, engineering, construction industry. Since 1964, at the time, productivity was same. But take a look at this non-farm industry. Nowadays, 2009, it's doubled. In other words, same money, twice times products they can create. By same people, same money. But in our domain, our industry, construction industry for buildings, some upside down, sometimes lower than 1, and not that enhanced, almost same. That's the big question. Why? Simply because non-farm industry, general industry, for airplane, for home appliances, mechanical engineering, they adapted some kind of technology-based approaches in terms of their business management strategies. Actually, my topic is not here. Actually, probably as a common sense, you may know what is MIS, Management Information System, or ERP, Enterprise Resource Planning. Also, lean manufacturing, Six Sigma, coined by Jack Welch, and so on. Human resource, supply chain management, customer relationship management, and so on. They are all certain kind of business management strategies based on technologies, mostly computing technologies. In other words, IT-based solutions for enhancing their productivity. But our domain, our industry got some very slow adoption of such IT-based solutions because we have some specialized environment. You know that. Our building is just one building. There is no prototype, no test model. When you build your building, That's it. No one destroyed the building and reconstruct it when they got some fail. That is just building. But people probably suffer from bad design or bad construction. Anyway, that is kind of final project when we finish our building project. But what if you design or manufacture cell phone? If you got failed product, just abandon it. That's it. That's enough because it's cheap. It's not several hundred millions dollars. IT-based solutions are very important to facilitate reducing cost, improving quality. In other words, getting higher productivity. But fortunately, nowadays, we got some revolving technologies named BIM, Building Information Modeling, and IPD, Integrated Project Delivery, that is IPD. They are so-called IT-based management strategies, in other words, in our domain. So we need that. Why BIM and IPD? BIM is Building Information Modeling. IPD is Integrated Project Delivery. Probably you may heard about it. Anyway, they are certain kind of strategic approach using technologies, using IT in our domain. Building project has a lot of participants, too many stakeholders. There are owner group, owner organization, facility users, managers, and designers, architects, structural engineers, construction managers for physically design and build that building. And there is schedule expert, estimator, so-called building organization, and subcontractors and amount of subcontract organizations for curtain wall, for material finish, for paint, for ceiling material, for mechanical engineering, electrical systems, plumbing, plumbers, and so on. And a lot of outside organizations also there. Too many stakeholders. That's our kind of intrinsic problem. There are too many stakeholders for just one building because it's kind of very large scale and a lot of money spent for a building. But my focus here is the term integration, integrated project, building life cycle with BIM, IPD, Lean, that kind of recently introduced buzzwords. They aim to get some integrated approach for the building project. This diagram simply shows you some very simplified building life cycle. Feasibility study, design, construction planning, construction, operation and management, and demolition at the end. Probably 100 years, 50 years, possibly thousands of years. From the birth of that building until it's going to be demolished, there are amount of changes in terms of their building life cycle. But anyway, our focus is how to reduce money, how to reduce some cost for maintenance, reduce cost for design, cost for construction, and enhance productivity or quality. That's the issue. How to do that? That's a very simple question, and we are struggling to get that answers. One of the answers gonna be BIM, analysis tool, IPD, Lean, and so on. They are all recently coined buzzwords in our environment, our domain. Let's talk about some BIM, as it literally means information. In terms of information, what are there? Firstly, some general and famous definitions. What is BIM? BIM is a model plus database. That's very simplified definition by AIA. American Institute of Architects. Probably you know what is database. It's collection of data for creating information. In advance, it could be a knowledge or a wisdom in a certain domain. So that database probably contains some data about that building. What is a model? That is so-called geometric computational model using AutoCAD, 3D Max, and so on. So when you design your model using SketchUp or 3D Max, that is a model and collection of data or information appended on your geometry. That is BIM. Very simplified definition. Another definition is BIM is a process done by, mentioned by Professor Chuck Gistman at Georgia Tech. He put an emphasis on the time axis. Model plus database, but it's up to its life cycle. Life cycle refers to that there is a time axis from beginning of the project, design, construction planning, and actual construction and maintenance until demolition. In terms of process, there is a time axis. So he puts an emphasis on we have to take a look at in terms of timeline for a building information model. There is this definition, but actually more specific and some representative definition is here. A building information modeling or model is a digital representation. Digital representation of physical and functional characteristics of a facility. Facility here means simply building, what you're going to design. Defined by Building Smart and NIPS. You can refer to this reference. This diagram also shows you building life cycle of building information. There are amount of information we create in terms of this process. Building life cycle is equivalent to the term life cycle of building information. In terms of process, the term modeling appended on this building information and modeling, that is BIM. Okay. When we plan this building, we generate some specifications, requirements, numbers, and some early cost estimate. And we got design, drawings, plans, some design review, and analyze them, simulate them, making some prototypes and physical models, and planning for actual construction. And amount of construction purpose simulation, such as clash detection and scheduling, 4D simulation, and so on. And then that's going to be erected on real site. But actually in our CAD class, our focus was visualizations here. Visualization is one major part of design, but it's not 100% of design. Sometimes it's very minor and tiny part of our process in terms of its life cycle. So my goal and my point here is put a little bit more interest on some process side issues except visualization, even if our class focuses on visualization of your design. Okay. So in terms of information accumulated according to the time, in the planning stage, there is no information, but we have specification, requirements, some numbers for area and so on. We accumulate some certain kind of information. And then we're going to move this to design company. So designers got something missing here. They design almost nothing. Of course, they got some documents from planners, but not everything. So they design again. They generate AutoCAD file, 3D Max visualization, rendering, and so on. After design, they hand them over to construction company. but they need some more information. So they design again using AutoCAD for structural analysis, engineering, and so on. So they accumulate amount of design for construction. As-built status is here. After construction, for maintenance, they hand some information over to building owners, managers, users. But anyway, they have to create their own AutoCAD plans for facility management again and again. So this is waste. But our goal is continuous information collection, seamless accumulation of building information. So conventionally, we got some information shrinking because of some problem, communication or some technical problem and so on. Our goal is seamless accumulation of building information model using specific technologies, environment, infrastructure, communication, and so on. According to the importance, the impact of information, this diagram is kind of famous McClamey curve. McClamey is the CEO of famous architects company, HOK. This axis will show you design effort and its effect. This axis shows you building life cycle, pre-design, schematic design, design development, construction documents, and agency permit, bidding, and actual construction. Kind of design process. But take a look at this number 2, cost of design change. When we change design in schematic design status, that is usual and that no problem because we are still design. What if we change our design when construction begins? The cost gonna be dramatically increased a lot. Number 1, ability to impact cost and functional capabilities. That's gonna be shrinking in this way. Traditional design process is this one, number 3. Our design information gonna be created and hitting the top when we are doing some construction documents done by some construction company, not designers. But integrated project delivery, that is IPD, I told you. Some integrated project, integrated approach for new building using BIM technologies, gonna be here. That's ideal curve, number 4. We have to accumulate, we have to hit the top earlier phase of design when we are doing some design, schematic design, or some design analysis using design development. In other words, we have to gather amount of information before construction documentation or even construction. That is the goal of integrated project delivery. And it's going to be possible by using BIM. That's the major thing to show you here using that diagram. According to that process, the importance of information, collection and reuse, and so on, there are amount of issues. But as you know, there are too many stakeholders. And we use SketchUp. Structural engineers, they need their own software. Simulators and building energy experts, they need their own specific software. There is no interoperable computer files. We have to export, import a lot, but it still has amount of problem. In other words, computational communication is very, very important in this kind of integrated project. But actually, there is a concept of open BIM. Open BIM is we have to adopt building information modeling. It doesn't mean that we have to use Revit or ArchiCAD. We have to use an amount of different type of files, but such information should be exported to someone who needs it properly. So how to share information with stakeholders? This video will show you some example. This video also generated by Graphisoft. Let's take a look at what is open BIM.
A building project has many participants, including architects, engineers,
consultants, constructors, and so on. They all have different roles, goals, agendas, and priorities. And firms usually run a number of projects in parallel. Combine that with the differences between building standards and conventions in different regions that require different solutions, and you'll understand why a single platform strategy is not the solution to the AEC collaboration. So if file compatibility is of little worth solving collaboration problems, let's see what the solution might be. Joe is an architect, Martha is an engineer, and Don is a constructor. They're working on the same building project and need to coordinate their work. Let's say Joe is designing a decent-sized building and needs to coordinate with Martha, the structural engineer. Joe sends his BIM model to Martha. And what does Martha get? The architectural BIM model that's full of architectural details. Such details are just noise for a structural engineer who needs only the load-bearing structures. So, she either cleans up Joe's model or starts the whole thing over from scratch. What we need here is workflow compatibility to ensure that the other party only gets elements relevant to her part of the job. Now that we've managed to get the appropriate part of Joe's model over to Martha, is she able to start her part yet? More often than not, the architectural logic of the BIM model doesn't 100% match the structural logic. For instance, columns in the architectural model may be modeled as walls, but the engineer really needs columns there for a structural analysis. What we need here is workflow compatibility to ensure that element interpretation is correct, regardless of the differences between the parties. Now we've solved these issues. Are Joe and Martha finally able to get to work with their respective models now? Sure, but as they progress, they continuously have to keep their work in sync. What we need here again is workflow compatibility to ensure that communication is bidirectional and that changes are handled in an intelligent way. You may have already noticed, but it becomes even more obvious once Don the contractor gets into the picture, that Joe and Martha were actually working on separate BIM models and only used the other party's model as a reference. The reason is that workflow compatibility requires that the real-world setup be mirrored, where parties carry full responsibility for their part of the project, hence, they also require full ownership of their own BIM data. As you witnessed in the previous 4 workflow issues, it's not file compatibility, but rather workflow compatibility that can make or break open collaboration between the various stakeholders of the AEC industry. With open collaboration, all participants of the AEC workflow enjoy unique benefits. Project members can choose to work with best-of-breed solutions in their respective field and location. Project members can decide about their software upgrades independently from their peers in different projects. Project coordination errors are greatly reduced due to workflow level compatibility in contrast to file compatibility. Accessibility of BIM data is provided throughout the entire life cycle of buildings, including construction and operation. To enjoy all these benefits,
you're welcome to join the Open BIM community today.
To sum up, this video showed you the issues in information sharing. Simply say, BIM model contains almost everything because we design together with amount of stakeholders, but not the one single integrated file is the answer. It's not the correct answer. We can export specific data, specific information to someone who may get interested in that information. So that is why this video shows you architectural model can be transformed to structural analysis model, and delivered to structural engineers, and integrated and some constantly and some correlated data management is important. When structural analysis done and some structural shape changed, architectural model also updated at the same time. That is very important. No redundant work required in that mechanism. That is the important issue. And let's get review building life cycle again. In terms of building life cycle, this simplified diagram shows you feasibility study, design, construction planning, construction, operation and management, and so on. In terms of building life cycle, I would like to put an emphasis on facility management. Actually, this is kind of some different story of our class, kind of last stage of building life cycle. But I would like to show you what is FM and how to manage facility management information using this simple video. Actually, this one for kind of advertising Autodesk solution for FM. But anyway, it's going to be useful for getting some ideas how to deal with FM in terms of computational tools among several different phases of building life cycle. Let's look at this video.
Most building owners understand the value of building information modeling, or BIM, in terms of design and project efficiency. In fact, a 2009 McGraw-Hill BIM Smart Market report stated that 70% of owners report a positive ROI from BIM while a building is under construction. But did you know that design and construction costs account for only 5 to 10% of the lifetime cost of a building? The vast majority of a building's costs come from the maintenance and operation of the property over time. That's why Autodesk, a leader in 3D design, engineering, and entertainment software, and FM Systems, a leading provider of facilities management software, have partnered to help bring the benefits of building information modeling to the operations and maintenance phase of the building lifecycle. Autodesk Revit provides the building design software foundation, built specifically for BIM, while FM Systems offers FM Interact to help enable BIM for the building lifecycle, a comprehensive approach to optimizing the business value of BIM that helps AEC firms and building owners to work together to drive down building lifecycle costs. FM Interact helps to dramatically reduce the time, effort, and cost of facilities management. It directly integrates with Autodesk Revit so building owners can connect BIM data from the design and construction phases to the facility management phase. Using BIM for the building lifecycle, owners and operators can build a detailed, more accurate space inventory, taking advantage of complex building model data to make more efficient use of their real estate. They can also populate maintenance management systems with building equipment, keeping an ongoing, more accurate inventory of that equipment. For AEC firms, FM Systems integration with Autodesk products can help differentiate services, offer added value to owner clients, develop new revenue streams, and maintain closer relationships with key clients. For owners, FM Systems BIM integration can help manage space and occupancy, maintain building equipment over time, and display floor plans for BIM models. In this presentation, you will learn how BIM for the building lifecycle helps to reduce time, effort, and costs in facilities management. And you will see how extending BIM into the operations and maintenance phase of the building lifecycle can help drive greater efficiency and significant savings. As an Autodesk AEC industry business partner for facilities management, FM Systems can help both AEC firms and building owners realize the business value of BIM data today. Let's get started.
Actually, the focus of this video was advertising their Autodesk software to integrate their design, analysis, documentation, and build and manage software. Anyhow, their application for FM supports Autodesk Revit file, even AutoCAD file, some their software products smoothly. That's the major concept of their software. But anyway, my point here is, anyhow, your information collected and gathered, stacked by your design process should be reusable and reused even in construction and facility management phase for a long time. That is kind of fundamental approach, and we have to achieve the goal, integrated project delivery until the demolition of that building. Okay. So let's get a look at the first phase of design, feasibility study and design. What happened using BIM? Actually, in feasibility study, there are many types of design guide requirements, some binding forces, laws. So usually Excel spreadsheet defines some special program requirements. How many rooms we need, how big spaces we have to build in our new building project. That is kind of feasibility study. Even by such information, we can estimate construction cost and schedule and so on using this kind of technologies. But actually, much bigger impact is on design phase. There are amount of design changes, process changes, but I would like to show you one of them, one big changes, space object oriented design, even in early phase of design. What is space object based design? Actually, this example shows you one case study introduced in the kind of textbook, BIM handbook, designed by HOK London. Also, software used in this project, the screenshot of this one is kind of Revit-based approach. Mass design to building. You know what is mass model. We roughly sketch building mass when we design to a specific building design. So he designed those geometry in 2D. This shape for bottom, and there is a hole, and the building middle shape, and the top shape. Simply, Revit generates this kind of mass according to that geometry, and simply create surface panel according to its surface geometry. This process looks very complicated, but actually it could be possible just within 5 minutes using Revit, because amount of automated parametric modeling techniques applied on this process anyway. So this example shows you, anyway, building mass is huge scale of one space object. Of course, there are amount of sub-rooms and sub-spaces, but anyway, this is one big change and something enabled by BIM, space object-oriented approach for the design. This is building mass to building design, but this slide shows you space objects, kind of room-based design. As you see here, those two floor plans are looking like some AutoCAD plan, but actually they are Revit plan view, Revit's geometry. In detail, there are no windows, no doors, no walls. They are just boundary of space objects. In 3D view, they are all 3D space objects, something like Lego blocks. There is no window objects, columns, slabs, stairwell, and so on, just space objects. We can separate some different purpose space objects in this colored objects. So based on this kind of space object oriented space-based design, later on we can add walls, columns, doors, windows, slabs, ceiling, and so on, something detailed. But actually, conventional process is kind of reverse direction. There is no space object. we usually draw walls first. But actually, our main goal is not wall. You are not wall designers. You are designers for space. Am I right? But ironically, we designed walls, windows, doors first for designing space, because design space means space boundary should be defined, physical objects. Space object is kind of void, invisible. It can be defined by surrounding objects such as walls. That is why you are designing walls first. That, I think there is a kind of irony. 100 years ago, Frank Lloyd Wright defines architect should design space, not walls, windows, doors, slabs, and so on. But there is an irony, but BIM-enabled approach for design changed this kind of process. You can design from scratch to space object for your final buildings. And then details can be added on top of those space objects. So let me quickly show you some differences between geometric AutoCAD file to BIM model. Conventionally, we draw something like this floor plan in 2D geometry, and we label it office. That means we can recognize, okay, this is a specific floor plan, and there is an office. But computer couldn't understand there is an office area. Computer understands that, okay, there are some series of points and polygon lines and text typed office. That's it. Computer has no idea this is building or not. But in BIM, for example, Revit, there is a room instance, room object. In other words, we can name it office and its department, space number, floor topology, net area, height, volume, geometric relations, topological relations, including 3D geometric data can be added on top of space objects. In other words, we can recognize, okay, this is a specific building's floor and there is an office. Also, computer can understand, okay, there is a building element and there is a floor and there is a space, and the space name is office, as well as amount of special information. Computer can understand what it is. Very big difference between those two different computational models. Even more information can be added thanks to external database, so-called collection of data, collection of information about that building. So we can add some standardized name, NC BOMA category, energy simulation related information, your occupant information, who's the owner of this office, something like that. Amount of additional information can be added on this model. That is the issue for information modeling, BIM. So designers have encountered some huge changes in terms of this kind of changes